Welcome back. Today we are going to talk about fuses. So we'll get into their purpose, why we need them, what they do, what they're made of, and then talk a little bit about application and about 8 different types of fuses. There's many more fuses, and we even use a lot of other fuses, but we're going to focus on just the basic ones. Yeah, let's get started. So what are the purpose of fuses, or what are they made of? Let's start there. So basically, we have a top and a bottom. This goes into a fuse clip. This is a conductive material, typically copper. And then in between them is an element that is rated for a certain ampacity. And when those amps are exceeded for a certain amount of time, then it will open up and break that. They're usually filled with like a silica sand so that when that explodes or that goes bad, it doesn't explode the fuse. Very rarely will a fuse explode. I don't see it anymore with these newer fuses. Older fuses, I've seen it. But typically they're very safe, but definitely keep your panel doors closed when operating, just in case. So yeah, that's basically it. Now, what is the purpose of the fuse? The fuse is for a few things. Extremely high overamps. So, you know, if you've got like something that's, you know, a 40 amp fuse in this case, and you're pulling 120 amps, it's possible it'll blow the fuse. Another useful thing they're used for is short circuit protection. So if you have 2 fuses in a system, taking 2 wires out, and somewhere in the ground or in that conduit or in that motor, there's a direct short will blow the fuses. Typically 1 or 2, rarely 3 fuses will blow all 3 fuses. It's very rare, but you'll see 1 or 2 blow in an application where there's a short circuit. Last but not least, what we've found they blow is during locked rotor amps. So if you have a motor, here's your shaft, and it spins, a bearing goes bad on your rotor and it locks up, or whatever your motor's connected to, say a pump end, locks up, gets something in it and it's locked and it won't free spin, the rotor locks up, it will blow a fuse on startup or even during standard runtime. If a bearing goes bad and it locks up, it will blow a fuse or 2 when it experiences locked rotor amps, that motor. So that's the 3 typical things we see a fuse blow from. Now there's some others, but it's not designed for that. And that is, if you have like a blade style fuse like this one, and you have a set of fuse clips that has gotten hot from thermal expansion, from just going bad, or for overamping, the fuse clips got adjusted or stretched during install, or just long-term heat exposure. Those fuse clips get weak, and when you slide your fuse in, it's weak and heat is generated there through the current passing through it, and it not having a good firm connection. Heat will generate, and heat will eventually blow the fuse up as well, and make it go bad. So it's always good if you have a round fuse. When you put it in, you want to make sure it's really hard to twist in there. Almost impossible would be ideal. And if you have a clip-in fuse like this, a slotted fuse, you want to make sure that you can't pull them out very easy. Sometimes pulling these out is a pain in the butt. You can, scuff up your knuckles, hit them on the panel. They do make fuse pullers, which are kind of nice. I've used them in the past. What I find with fuse pullers is they typically break. They're made of plastic or fiberglass, and they're kind of cheap. So if you have your power off and you've tested your power, a pair of channel locks on here, water pump pliers, a pair of needle nose even, you can grab these fuses and pull them out. So that's kind of what we see there with fuses blowing. Keep in mind, once more, if your fuse clips are bad, you're going to prematurely burn fuses up, and you're going to be experiencing, fuses burning that you're assuming are something else. Remember, that word in electricity is a terrible word. Assuming is not good in electricity. It can kill us. But, taking and making sure your fuses are tight, making sure that everything is good, very important. So now getting on to the fuses themselves, we have 8 different types here. This is going to take us all the way from 1 amp to 200 amps of standard fuses, standard disconnects. So we're going to start with a 230 volt. This is a 20 amp fuse, 230 volt, 20 amp. This fuse is in a frame of 0 or 1 to 30 amps. So a 30 amp fuse, a 5 amp fuse in this model, the TR20R, would look the same. It would just have different amp ratings, different ampacity ratings. So this is a 230 volt 20 amp, and it's in the frame 1 through 30 amps. So if you had a 30 amp 230 volt fuse, it would look just like this. It would go in the same disconnect. It goes in a 30 amp disconnect. Moving on to the 60 amp 230 volt framed fuse. This one goes from 35 to 60. This is actually an FRNR 40, so it falls into that category. This goes in a 60 amp 230 volt disconnect or pump panel. Same disconnect mechanism though. So this one, 35 through 60 amps. You can see it's a little smaller, so your 30 amp, your 60 amp framed fuses. And then last, well, not last. Next is your 100 amp frame fuse. It goes into a blade type with, they're not round anymore. And this is actually a 100 amp 230 volt. And I'm saying 230 volt because that's the voltage we see, 230, 240, but they're actually rated for 250 volts. You can see the rating right on it. If you can see that, I don't know, but that's it, 250 volt rated. So this will work from 65 amps all the way to a 100 amp, and it goes in a 100 amp disconnect. So 65, 70, 80, 90, 100 amp. 240, 250 volt rated, 230 volt fuse. Last in the 250 volt application is a 200 amp frame fuse. This one's getting a little bigger. You can see it's a little bigger than the 100 amp. This is a 200 amp frame. This one would go anywhere from 110 amps to 200. So it covers a larger realm of ampacity, all the way from 101 amps to 200. So that goes in a 200 amp disconnect, and it's rated once more for 250 volt. And these do also have a DC rating because they use them on DC, like solar and other things like that, but we don't use them for that here. So keep in mind that you're going to run into in the wild, I always call it in the wild because you're out there in the wild, and you're going to run into applications where you have the wrong rated fuse. Now, it is okay to have a 480 volt fuse that is running a 230 volt system because it's rated for up to 600 volts. It'll say right there. But it is not okay to have a 250 volt fuse running 480 through it. So just keep that in mind. If you have an application in the wild where you find that, you have a 250 volt system that has, or a 480 volt system that has 250 volt fuses, that's a no-no. That should be replaced and changed. You should talk with your customer, the end user, and recommend that. And when we run into things like that where things are exceeding ampacity ratings, if the customer doesn't want to change it, we take a pretty strong stance. Say, hey, we really don't want to service this thing if you don't want to make it right. Because there's lives at stake here. It's not worth it. Both the people out there working in it, working around it, and us working on it. If you have to, for some reason, start a motor or a pump with the door open to get amps or something, and that fuse isn't rated for it, it could blow up, it could damage you, it could damage things. So we definitely want to stick within our ratings. 250 volt rated fuses, 250 volt or less. 600 volt fuses, 600 volts or less. You can't put more than 250 volts to this fuse. So that's your 250 volt fuses. You can see them all here. I'll put them all side by side so you can look at them. You've got a 30, 40, a 30, a 60, a 100, and a 200 amp frame fuse. So that's them. 250 volt rated. Now we're going to move on into the 480 volt side. And you're going to see a big difference in how they look. They're bigger. So this is your 30 amp 400 or 600 volt rated fuse. This is for 480 volt. And look, this is your 30 amp 600 volt. This is your 30 amp 200 volt, 250. So once more, if you have 480 volt traveling through this, that's wrong. It needs to be changed. So this one here is a 15 amp fuse. Once more, it goes in a 30 amp frame disconnect. So if you have a 30 amp disconnect, you can put this fuse in it all the way from 1 to 30 amps in that standardized disconnect. It is a round one, so once more, put your fuse in. If they spin easy when they're in the clips, then you're looking at changing that disconnect, because it's going to generate heat and create issues down the road, callbacks and such. Here is your 480 volt, 600 volt rated 60 amp fuse. You can see they're just a little taller and a little wider. So this is for your 60 amp disconnect. This would go from 35 to 60 amps. And that's it. Basically 600 volt AC, and these are rated for 250 volt DC. Once more, for that photovolt systems. Next is a 100 amp 600 volt rated fuse. This is a blade style now, and this one is a 70 amp, but once more, it can go from 65 amps to 100 amps. So anything in that realm will fit, and yeah, that's for a 100 amp disconnect. And this is our 200 amp disconnect. You can see it's a little bigger. You can see the blade is thicker. It's made for more amps, made for more ampacity. This one happens to be a FRSR 175, 175 amp fuse, rated for 600 volts AC, and it goes in a 200 amp disconnect. Same thing, same idea, is 230. This one would be all the way from 105 amps to, or 110 amps to 200 amps, so a wider range. And that really encompasses fuses. We're going to give you just a quick look. You've got your 30, your 60, your 100, and your 200 amp fuses in 600 volt rated. And that basically covers all that we're going to do on the standard fuses here that we use for pumps and motors in this industry. I hope this helped. I hope you learned something. Have a blessed day.